So now I'm going to talk about the some basic properties of liquid. So let's move to the first one, which is what is diffusion. So let's discuss that. What is diffusion? Wait, I need to increase my font size so that it will be visible. So the first that we have is the diffusion. Diffusion. Now, what is diffusion? Diffusion, basically, if I can write a proper definition of diffusion, I can say that it is a sudden or a intermediate or a sudden collision or mixing of the molecules. Collision, it is sudden mixing due to collision of the molecules. It is a sudden mixing due to collision of the molecules, or it can be also described as a collision of the molecules, the collision of the molecules. Or I could also say that it is a movement of molecule. It is also a movement of molecule. It is also movement of molecules. I'm sorry, from a region of higher pressure, region of higher pressure to the region of lower pressure. What does it mean? It means that now you can see here, for example, I can create some basic like this. So wait for a while. This is basically a molecules of the liquid which is inside. For example, these are the liquid molecules. They have very less intermolecular spaces. Oh my god, it's such a huge. We can ignore it. Okay, the giant molecule. We can make inside it. Yeah. So we can consider as that all molecules are spread throughout this container. So as you can see that there is very less intermolecular spaces due to which their movement is restricted. However, they don't have a significant amount of collision between their molecules, which means their collision is restricted as well due to their very less intermolecular spaces. And yes, if these are the two molecules of liquids, so their force of attraction do exist between them. The force of attraction do exist between them. That's why the rate of your diffusion is also less. The rate of their diffusion is very less just because force of attraction is acting between them. But if you're going to increase their temperature, for example, you have increased their temperature, so what's going to happen here now? Let me show you again what's going to happen. For example, this is after the increasing the temperature. Okay, wait. Let's take this color. Now you have increased the temperature. The molecules are moving far away from each other, and now the force of attraction that exists between them is negligible. Just because their kinetic energy, the molecules gains the kinetic energy, and now it moves far away from each other, due to which now it does have force of attraction, but it's negligible due to the high kinetic energy, and now the collision between their molecules is high. Diffusion happens just because of the collision between molecules, or collision or kind, and they have a restricted kinetic energy as well between their molecules, just because they have intermolecular forces between them, and they have to have intermolecular spaces, but that's only intermediate, or I guess neglected or something like that. Yeah. So what's going to happen when we're going to increase the temperature? The molecules move far away from each other. As you can see here, now for instance, we can suppose that now I have dropped here here let me make it. This is a drop of water. Now it will diffuse throughout the water, but I can say not in a very short span of time, but it does require time to spread throughout the container, to move from region of higher pressure to the region of lower pressure. So in gases, the rate of diffusion is very fast, while in the liquids, the rate of diffusion is low. Just why? Just because of these intermolecular spaces. And when you increase the temperature, the molecules gain kinetic energy, and they move far away from each other, due to which their rate of diffusion increases as well. So I can say that a diffusion in liquids take place because of the molecule move from the one place to another place due to kinetic energy, and the restricted movement of the molecule reduces the rate of diffusion. For example, when an ink is added into the water, it diffuses slowly due to relatively smaller, or I could say the due to smaller spaces between your molecules, right? So if you're going to increase the temperature, the intermolecular spaces increase as well. So yeah, this is the one physical property. Now I'm going to discuss the next as well.